So my project looks at how graph theory can be applied to problems in network connectivity. The following problem utilizes an algorithm called the Ford-Fulkerson algorithm, which calculates the maximum flow within a network. Here is how I applied it. So I recently came up with this problem where I have a file from a source computer that I'm trying to send over to a destination computer, but the source and the destination are not connected in any way. So instead, I have to send parts of the file through a network which will get compiled in the destination at the end. Each computer in this network is connected in a specific way. So the source is connected to both my laptop and my mom's laptop. My laptop is connected to my mom's laptop, and both of those laptops are connected to the destination. Now, each edge between the vertices have a maximum capacity, right? So the maximum capacity between the source and my laptop is 4 megabytes per second, and that 0 you see in front is what is currently being sent through. So now the goal of this problem is to find out how can I maximize the amount of data that my destination is receiving, right? So the maximum flow throughout this network. Now this network is relatively simple, and you'll see that the answer will lead to something trivial. But to begin, what I'm going to do is I'm going to pick a path at random from the source to the destination. So I'm going to go from source to the A to B to destination. And the maximum amount of data that I can send through this path is limited by 4 megabytes, right? Because of this edge. I cannot send more than 4 megabytes from that edge. So I'm going to update all those values and add 4 there. And now what I'm going to go do is update this graph down here called the residual graph. And the residual graph will help me determine if there are any suboptimal solutions that I'm coming up with. And you'll see why in a second. So to draw a residual graph, I'm going to follow 2 rules. So I'm going to draw a forward edge, and a forward edge is an edge that kind of points in the direction of the destination if the capacity minus the flow is greater than 0. And I'm going to draw a backwards edge, so an edge that goes from the destination to the source if the flow is greater than 0. So let's start with the edge from S to A. We see that up here, the flow is greater than 0. So I'm going to draw a backwards edge, which will be in red. And now from A to B, I'm going to draw both a forward edge and a backwards edge. So the forward edge will be 1, and the backwards edge will be 4. And same with the edge going from B to the destination, 4 and 1. Okay, so now let's find a new path. I believe there's one path that goes from the source to B to the destination, and I can send a maximum of 1 megabyte per second through that path. 1, 5, and add 1. Oh, let me just update the residual graph for a second. Send 5, and this one is going to be 5. So based on both the residual graph and the flow network, it appears that there's no path in which I can send more data to go to the destination. And so it appears as if the maximum flow in this network is 5, but this is not entirely true. In fact, one thing that the residual graph does show is that there is a suboptimal solution. We see that there is both an edge that can send more data from the source, right? And there is an edge that will allow us to send data to the destination,
and there is a bridge between those two areas. So what I can do is I can go, let me go back to my flow network and say, okay, well, I'm going to ignore the direction of the edges for a second, and I'm going to say I'm going to send 2 megabytes of data through this blue path right here. 2 megabytes of data. So let me add those two values over here. So I'll be sending a total of 3 and 2. And instead of making this 4, I'm going to do something else. I'm going to say 4 minus 2, and I will get 2 megabytes is going to be flowing from A to B. And I'm going to add that there and find that the maximum flow in this network is 7. So I'm going to quickly update the residual graph just to confirm that the answer that I believe is correct now is true. So I'm sending 2 megabytes that way, and I'm sending 2 megabytes this way, and 3. And then I am sending a total of 3 in this direction, which means a total of 3 going outwards. Okay, now if we look, we see that both the edges that supposedly lead to the destination are now pointing in the other direction, which means that we cannot send any more data through this network, which therefore confirms the answer that we found up here, is that the maximum flow throughout this network is 7 megabytes per second. Now, I did do a real-life experiment where I actually did connect these laptops and limit the data sent and received, and I did find that at the destination it was receiving a total of 7 megabytes per second, which is the exact number that we found to be the maximum flow. Now, earlier I said that this answer is trivial, and the reason why is if you look at the two edges that initially lead to the destination, the maximum capacity is 2 plus 5, which equals 7, which is the same as the maximum flow. However, if this network was a little bit more complicated and the values were shifted, we'd see that there are times when the capacity leading to the destination is not always going to be the maximum flow. Thank you.